Good evening, good day, everyone watching. Thanks for tuning in again, hopefully. I'm Dave, as you might know, and today we will be looking at some exciting stuff, some easy stuff. Node.js IOTA interaction for beginners, basically. So we will walk through a couple of steps where we will be interacting with the Tango in various ways. First, we'll do some hello world kind of stuff. Maybe I should change my name later, but it's not my highest priority right now. Hey, Ryback, what's up? So how are you guys doing this night? You have nothing better to do in your Saturday nights, or? Just kidding, just kidding. So yeah, what I have here is a virtual machine, fresh virtual machine, nothing really installed on it. And what we will do is we'll just run through the examples and hopefully we'll learn something new today. For this video, we will be using a repository created by Lewis, my ecosystem colleague, manager. He has it available on GitHub for everyone to clone. So if anyone wants to have a go themselves, it should be a chill stream to watch with a hangover, I guess. It's not too fancy what we're going to do, but it's very useful if you haven't interacted with the Tango before in Node.js. My Node.js is a little bit rusty, but I think we will manage. Hey, what's up, Rock? Okay, so I pasted the repository here. Let's go ahead and get it ourselves. So we'll do a git clone IOTA workshop, and then we have our IOTA workshop. Yeah, so this is basically a sort of introduction to IOTA in Node.js. It can be used on like workshops and stuff. So we need to install the dependencies first. This will look at our packages. So basically it has a couple of dependencies. It has the IOTA core library, which is a TypeScript library for IOTA. The IOTA mem library, which is just the masked authenticated message library in JavaScript. And a 0MQ library. This is for our 0MQ part of the tutorial. Yeah, I will be covering 0MQ and mem as well today, so should be interesting if you're looking for that. So let's install our dependencies. Yeah, it's a fresh installation. So let's install Node first, and we run into our first error already because it can't find npm or Node. This is probably because we don't have the multiverse repository in our fresh server installation of Ubuntu. So let's look up how we're going to get the multiverse. It's something sudo apt repository. Yeah. Add apt repository multiverse, and that should give us enough stuff to install Node and whatever. And if you have any questions at any moment, just feel free to ask them in the chat. Hopefully I can answer them for you. So let's see if we can install npm now. Yeah, there we go. So this shouldn't take too long, I guess. We'll see. Not sure why it needs Python, but hey, what's up, Simon? see Tyler is watching as well. He's responding in the Discord. It's always good to have a Twitch account when watching, because you can actually follow me and you'll get a notification either on your phone or in your email. This will help you if you want to watch the further streams I will do. When new transaction structure? I don't know anything about that at the moment, so I'm not sure if I can answer that question for you. It might be a good one for a AMA with the engineering team later. Not sure when that will be happening, but we'll probably see a board AMA first. Okay. So basically in this code folder we have, starting from the most simple instruction, we have a hello world, send hello, fetch hello. These are all very simple interactions with the DevNet. When 100%? Soon, dom soon. Soon TM. There we go. Let's see what kind of version of Node we have now. 8.10 works for me. Let's install our dependencies. So this will install the dependencies from the package.json file, the IOTA core, the mem library, and 0mq library, which will be used for our 0mq example. I use npm because it's the easiest to install right now. Yarn is fine as well. We can use Yarn. They work together, sort of. But yeah, during these tutorials, nice hop. Yeah, so during these examples, I will often take the easiest way in terms of dependencies, so we can keep it easy. You don't have to deal with a lot of dependencies. Now, Yarn isn't a really big dependency, but yeah, mem is going to get a new revision. That's perfectly right. Some people are hard at work with that. We will hear a bit more about that in due time, but yeah, we'll get a new version of mem with public key encryption, private key encryption, and some more improvements. I'm not too sure what I can tell about it at this moment, so I will shut up about it. We installed our dependencies, so let's have a look at the first example, hello world. This is our first example, and this will basically check on this wonderful node cluster here. Don't charge me any money for it, Mathieu. It will get the information about the node, and it will return it in my console log. So basically what this does is it checks our node information and it will print it out for us. So let's see how that works. There we go. When I have more transparent DOM soon as well. So yeah, we have this information here. So this basically tells us something about our node we are connected to. So this one is running on version 1.5.5. It has 8 available processors. Not really that useful to know, but we also know a little bit about the milestones being available. You can see a latest milestone index and the latest solid subtangle milestone index. If these are both the same, the node is in sync with the rest of the network and it can be used. So this one is perfectly fine. It's a DevNet IRI. And we're going to be working on the DevNet for now, just for demonstration purposes. It is a bit more fast. It's a bit faster because we have a lower minimum weight magnitude. It's 9 instead of 14, which means that we can do our proof of work a little bit faster. Doesn't really matter with if we're using the nodes from Mathieu, because they use the FPGA, how do you call it? Wow, okay. You hear that hop up? Don't add him. So yeah, it uses the FPGA, it doesn't really matter, but let's use the testnet since we're doing some test examples here. So yeah, basically this is already an interaction with a node, and all we needed is these couple of these lines. This uses the IOTA core library, the IOTA.js library. We can find the documentation for that on github.com/IOTA-ledger/IOTA.js. PyDiver, yeah, that's right. And if you want to know a bit more about the IOTA library and all the available functions you have, just have a look at the documentation portal, click on the JavaScript library. It's docs.iota.org. Should be easy to follow. So not much more to say about this one, I guess. Unless anyone has any questions, let's continue to the second one. Let's do some actual interaction with the Tango. So here we have a example where we include the IOTA core library. We connect to our DevNet node here again. We are going to publish to this address right here. And we're going to use this seed to do it. And we will be sending a 0 value transfer with a hello world message to the address we have listed here. So this is a transfer object. And basically we call the initiated IOTA.js library. We call prepare transfers with our transfers object and our seed. And then we send our tries using a depth of 3 and a minimum weight magnitude of 9. This should be 14 on the mainnet. This basically tells us how complex our proof of work will be. The higher this number, the longer it will take to do your proof of work. 9 is the default for the DevNet, so we'll use that. We can use 14 on the mainnet. Might change in the future, but for now that's it. How much IOTA is in that seed? I don't know. It's basically from this repo, so I reckon there is nothing on there. But finders keepers, I guess. Nice. Yeah, it's on the testnet, so it doesn't really matter. If anyone wants to test on the testnet, by the way, and needs some tokens, there is a faucet. Not sure if I have this correctly. No. Faucet.devnet.iota.org. Here it is. So if you have a actual address where you want some IOTA on, you just enter the address right here. You click the I'm not a robot, and it will send 100 IOTA to that address from the faucet. This will give you some testnet tokens in an easy way. If it for some reason doesn't work or whatever, you can always DM one of the mods or me or whatever, and we probably have some access to them as well. I know Johnny Milkshakes has some testnet tokens to distribute, and some other mods as well, so that's an option as well. So yeah, basically we're creating this message, we're sending it using a minimum weight magnitude of 9, and we will then check our bundle. We'll log it to our console. Let's change this address around a bit, because it's probably being used a little bit. Let's see. So we'll change it to this. And let's run the script. Okay, so here we have our bundle. You can see our address here. You can see our signature message fragment here. If we're just sending a message, zero value transaction with a message, our signature message fragment will just contain the message we entered. This can be JSON encoded as well. It can contain other stuff, but that's a way of sending messages on the Tango. It's the same thing that, for example, mem uses as well. Okay, so we actually sent this, so let's see if we can find it. Definite.thetangle.org. This is our address, and there it is, our zero value transaction. It has already been confirmed on the testnet, devnet. And there we have it, our message, hello world, in trites. So yeah, that's basically a very easy way to interact with the Tango. As you can see, you only need a couple of lines and a little bit of basic information to get going. As you can see, the message here is just a simple, this is trites already. So let's see what it does if I enter something that's not a trite, for example, a couple of ones. Let's see if it gives an error. There we go. So now we get an error. Why do we get an error? Because we entered the 111 here. This message field, it expects trites. Trites are uppercase letters, so A to Z and nines. Ones are not included in trites. We can't send this. So if we change it to 9 and 9, it will work. So yeah, if we want to do something else, put something else in there that's that contains something else besides trites, we have to encode it into trites first, and we'll look at that in a little bit. Let's look at another example, fetching transactions using Node.js. So if this is going too fast or it's too difficult, or if you need some more information on something, just ask and I'll try to answer it. So this will connect us again to our devnet node, same thing. We have an address. We don't need our seed here because for fetching transactions we just need the address. And we use the find transaction objects function. Let me see. Find transaction objects. And this takes a object called addresses, and it contains a list with our address in it. You can give this other parameters as well. So for example, bundles. Yeah, just have a look at the website. IOTA is a distributed ledger technology, sort of similar to blockchain, but it works a little different. There's some explanation about what it is on the website. I recommend you have a look at that. And it's also a currency for the gods, according to chat. So yeah, you can give it addresses, bundles, tags, approvees. In this case, we just want to see the transactions for our address, but we could say we want transactions with a certain tag. We can do that as well. And once it fetches those transactions, it will just log them in our console. So let's put our address here, the one we just used, and we sent two transactions with a message called hello world in them to that address. So those should show up now. There we have it. Let me know if this mic volume is okay. If I put it too high, there's some interference, I guess. It should be a little bit better now. Tell me if it needs more upping. So here we have our two transactions. Both have hello world in the signature message fragment. Static. That's what I mean. I'm sorry, I'll move the mic a little bit closer. I hope this is better. I really need to do something about that. I have a shitty audio interface. I need to get a better one. So here are our two transactions. So in these last 20 minutes where we have been, sorry Faye, where we've been looking at this, we have already checked the node information, we have already sent 2 transactions to the Tango, we already retrieved them as well. So if you know the basic stuff about how to use the libraries, it is actually quite simple to interact with it. You just need some boilerplate, I guess. Let's see what we have now. Example 3.1, create address. So here we go with the same stuff again. So, okay, it tells us here we need to get a seed first, because we're going to generate a new address based on the seed. Yeah, that's right. So if you look at the transaction right here, you can see the nonce here. It says powsrv.io. This is the proof of work service that's being used. This makes sure that a FPGA is being used for the proof of work, which means it's a lot faster as doing this via your CPU or GPU. This makes it do the proof of work for a transaction within 3 seconds or something, instead of 10 or 12 or a little bit more, depending on what you're using. That's one way to look at that. So let's generate a seed for us first. So we have a fresh one. There we have one. Of course, this is very bad practice to do this in a live stream. I would not recommend that, definitely not for a live seed you're actually going to use, but we're on the DevNet now, and this is just for this purpose. So I'm going to do it anyway. We'll paste it here. I agree with you, Mathieu. The minimum weight magnitude of 9, it's actually really quick to do the POW4, so no real need for FPGA on that. It is cool that it's available though. Get new address for our seed with index 0 and total 1. What this tells us is that it will generate the first address for our seed, and only a single address we will get. Yes, I'm using Ubuntu server 18.04.1 LTS, so not the desktop version, and in a virtual machine. So if you want to replicate this, you could use that. Just don't forget to add the multiverse repository for Ubuntu, so you can install Node easily. And basically that are all the dependencies you need to follow this tutorial. So let's generate our first address. Options are deprecated and will be removed in version 2.0. Okay, we will have to refactor this one a bit later, but here's our first address. Yeah, we can actually send tokens there if we want. What I want to note is if we run it again, we will get the same address. And this is because of our index here. Let's have a look at this this function in the documentation. Get new address. Index, key index, security 2. Checksum, total, return all, callback. Let me tell you a bit about these options. So the index is the key index to start at. Fulfill hash, new unused addresses or a list of addresses up. First unused addresses. Okay. First of all, the index. This will tell us which index we're at. We're currently at index 0. It means the first address for our seed, or first unused address for our seed. Security, that's 2 by default. And this is the default security level for most transactions, most valued transactions. If you use a transaction, if you send a transaction if you use Trinity, for example, your addresses will be generated using a security level of 2 as well. There's an option for 1, which is a little less secure, and there's an option for 3, which is more secure. This will also tell us how many messages our signature will take. So with security of 2, we will need 2 messages in our bundle with our signature. With 1, we only need 1, and with 3, we need 3. So basically, if we send a value transaction, it will most of the time have 4 messages inside them. Let me see. So there's the output transaction. This is if you're sending money to someone or IOTA to someone. This is the transaction where it's actually sending them the IOTA. The input address of the transaction and the first part of the signature, so where the transaction is coming from. The second half of the signature, because the signature is too long, it needs 2 messages for that. And the third one is the output address for the remainder. So say you're sending 1 IOTA to someone and you have 100 IOTA. The 99 remaining IOTA need to be sent to a new address, because you cannot send IOTA from the same address twice. That would be unsafe. So you will always have to send the remaining IOTA to a new address. This whole bundle construction is being done by our library, which is great because we don't have to think about what we have to do there. We will get to that in a little bit. And okay, the checksum. This can be added as well to your options. This will add 9 characters to your address. If you want to use your address distributed to people so they can send IOTA to it, give them your address with the checksum, because otherwise they won't be able to send IOTA to it using Trinity, for example. This checksum part is just meant for making sure that you don't have any typos in your address. So let's see, checksum true. Let's run it again. And as you can see now, we have the same address right here, but it has 9 characters behind it. And if I have a typo anywhere in this address, it will be detected by Trinity and it won't send the transaction. So it's basically a security measure to make sure you don't have that. But yeah, let's take our generated address here, and we'll use the faucet. Address is valid. I'm not a robot, I guess. And request. Your allocation request has been successfully processed. Please check your balance in a while. So we actually requested some testnet tokens now on our newly generated address, and we will use this in our next example, I guess. So let's have a look at that one. In the meantime, feel free to ask any questions. Let's copy our address once more just to be sure. This is our newly generated address, get balances. So we connect to our node again. We request our get balances function. So let's have a look at that one. Get balances, address threshold callback, addresses. So basically we give it a list of addresses at the threshold. I'm not really sure. It's not really explained here what the threshold is about. This will probably be just checking the first 100 addresses until there is like an address without any transactions on it, and it will stop there. Because a single seed has multiple. No, that's not the truth, because we're using a address here and not a seed. I actually don't know. If anyone wants to tell what the threshold is in this case, feel free. I don't know this out of the top of my head. But we're getting the balances for... oh, this is probably just the amount. So we'll get up to 100 transactions for our addresses here. So a single address will check what the balance is and we'll print it to our console. And there we have it. We have 1,000 IOTA in our address already. Let's see what happened. Here we have our address. And here we can see that our faucet transaction has already been confirmed. So we got 1,000 IOTA to spend right now on this seed. Don't steal them from me. I will have to do it again. If you're a troll, do it. So yeah, we already received some IOTA. Let's check what we have next. Sending tokens. So we're actually going to do a value transaction now. It's not real value in this case because we're on the testnet, but it will work exactly the same on the mainnet, apart from the proof of work, which will be harder on the mainnet. It will be a minimum weight magnitude of 9. This is a little bit of a longer example. So first we connect to our trustworthy DevNet node again. Hey, what's up, Grandpa? How are you doing? Replace this with the seed you sent the tokens to. So we need the seed which we used before, 3.1. Let's copy this one. There we go. Because we're going to send IOTA, we need our seed in order to sign our transaction. Here we have a function we're going to call right below at the bottom. We are using Async Await right here. This is a method of waiting for asynchronous methods to be called. Let's see, await. Is it being used actually or no? Yeah, here we go. So if we call await here, it will actually wait for this asynchronous function to complete before it continues our the rest of our function here. You can't use await outside a asynchronous function, so we actually have to wrap it inside this function. This comes down to something similar as callbacks or stuff like that. You have several ways of doing this in JavaScript, and this is one of the more modern ways. Threshold is currently absolutely not used by the IOTA on get balances. It just rejects requests where the threshold is not between 0 and 100. Oh, thanks for that info, Mathieu. Okay. So what this will do, first we get a new address for our seed, and it will use our first index. So we already, or index 1, which is actually our second address for our seed. The first address we have here, this already contains 1,000 IOTA, but we're going to generate a second address using the index 1, and we will create a transfer. The transfer has a value of 500 IOTA. This is always in IOTA, not in myota or KIOTA or whatever. Always give the full value here. From the receiving addresses, it gets the first address it generated, which is our second address for our seed. And it has a tag here. Let's give it another tag. We'll call it Johnny, because he was late with his response. Okay, so we created our transfer here, just a single value transfer to our address with the tag Johnny. We will write in our console what we're doing. We're sending 500 IOTAs. Then we will call the prepare transfers function, and let's get the documentation for that. Right away. So this actually takes our transfers and it converts the whole transaction into threads. Could be quite handy. So this will create our thread bundle basically. and it returns the threads which we need to send to our node. So once this has been created using our seed and using the transfers object, which we have right here, we will send our threads to our node. We will indicate that we want a depth of 3. You can change it, but 3 is a good default. And a minimum weight magnitude of 9, which is used for DevNet. Again, if you're using the mainnet, replace this with 14, and you'll be good. Depending on the nodes you're using, if you're using a remote proof of work or not, sending the transaction can take a while, because we actually need to send 4 messages in our transaction bundles. It's a signed transaction, so it could take a while, but using our DevNet node, especially with the FPGA proof of work and our minimum weight magnitude of 9, our difficulty of calculating the nonce, it should only take a little bit. And once we're done, it completed transactions, and it will output our transactions to our console, or if something went wrong, it will output the error to our console. So let's see. Send the tokens. That's our new address. That's the second address for our seed. And there we have our transaction. So as you can see, this is our full transaction. It has multiple messages, or this is our bundle actually. It has multiple transactions in them. Like I mentioned here, the output address of the transaction, this is the first one. If you want to send a message along with this, that's possible as well. We might get into that a little bit later on. The output transaction, since we're sending it to someone else's account and it's not deducting any IOTA, we don't need a signature in this one, so we can fully use this signature message fragment field. This is the address we are sending it to, 500 IOTA, and it has a tag. It created HRHNNI. We didn't enter that. I'm not sure if I can explain the behavior, but I've seen it before. Might just be the visual representation in threads here. This is our second one. This is the input address. So this is actually the first address which we used here, RSAO, and it's deducting 1000 IOTA from the address. This is the part of my signature, the first part of my signature, which I need to send this transaction. Minus 1000, and here is my second part of my signature. Since this is just the second part, it doesn't have any value. It does have the same address as my input address. And then we have the remainder address. This is actually the address where the tokens are being sent that remain. So we had 1000 IOTA, we sent 500, we had 500 remaining. Those 500 remaining are being sent to this address. This is the address on my seed as well. It might be the same as this one, maybe. Yeah, here we go. So it's actually the same address as the one we generated, because what it will do is it will generate IOTA to the, it will send the IOTA, remaining IOTA, to the first available free address for your seed. So if we're going to check this address right now, we should see 2 transactions. One for 500 and one other for 500. There we have it. So one of these is the 500 IOTA sent, and the other is the remaining transaction. Usually you don't send to your own address. So most of the time this will just contain the 500 IOTA, and some other address will have the other one, because we send it to ourselves, using making sure that we're not reusing addresses. Of course, we have a new address here. We have both transactions in here. Let's have a look at one of them. It has been done with the POWs as SRV as well. This is the remainder transaction because it has the empty message. And oh, here is the tag is Johnny, so that's okay. Tag for this one, yeah. This is empty, so this is the remainder transaction, and this is the normal transaction. We can have a look at our full bundle as well. Where do I click? Bundle, here we go. And here we can see what we did. Our input address, we sent 1000 IOTA, 500 to this address, 500 to the same address. And this is our second part of the signature. This is a very typical way of sending a value transaction in IOTA. You can have value transactions as well with multiple outputs, multiple inputs. You don't have to have every IOTA on the same address, input address. You can have multiple input addresses and send it to a single address or to multiple addresses as you please. What a lot of exchanges do is they send so many transactions, they want to bundle them. So they wait until they have like 50 and they send them all 50 in one bundle. Because if a bundle is confirmed, all transactions within the bundle are confirmed. So they don't have to wait every transaction for the next one to confirm before they can send another one. They can just send 50 at once and make sure that confirms, and then they can continue with the next 50. We can do the same. Yeah, it's nothing magic. A rule for a bundle is that the amount of IOTA you're sending should be exactly the same as the amount of receiving IOTA. So it should add up, and the funds should be available. Theoretically, you could even say, I want to send 2 IOTA to my own address. And that would actually confirm because it's a valid transaction. Since you're sending 2 IOTA and you're receiving 2 IOTA, it ends up being nothing added to your account. But this might result in some funny looking transactions in the Tango and some questions in the Discord about it, which we've had a lot. So if no one has any specific questions about this, I might continue, but feel free to ask them in the chat if there are any. We're coming along nicely here. We're already at point 5. We will be looking at the more advanced examples a little bit later, starting from point 6, ZMQ listen, which might be interesting for some people who already did this basic stuff. Sending data. So this is very similar to sending value transactions. As I've shown before, you can send just a message, but it have to be tried. And since we can't put anything in a thread, we will get an error there if we don't convert it first. So we have a seed here, we have an address here. Let's get our Twitch address. Let's see. Okay, this is a new one. Actually, it's a little bit different from the last. Let's think of a message that not valid writes, so I can show you what this does. Let me think. Hello, speculation. V3, not V2. I think that's a nice message. This wouldn't work if we wouldn't use this converter function. What does this do? Maybe the documentation will tell us something about it. ASCII to threads. This is not my search. I don't usually there we go. Use Firefox, ASCII to threads. Converter ASCII to threads. Converts an ASCII encoded string to threads. So basically we can just input any valid ASCII character here. I'm not sure about Unicode, I think it's Unicode as well. And it will convert it to our threads. This will look a bit weird if we look at it raw, because threads, if you convert this to threads, it might not say hello speculation, but something very, very different. It basically uses a standard way of encoding stuff using threads. Why are we doing this conversion? Why do we need threads? Well, we're using ternary throughout the IOTA libraries, and this is something we use to future-proof transactions for ternary hardware, basically. So we're doing this now. It's a little bit of a hassle sometimes, but it will make sure that if we have ternary hardware in the future, it will work good with this as well, and we won't need to change the protocol later on. We're going to send a zero-value transaction from our seed to our new address here with our thrice encoded message. First, we create a bundle with the prepared transfers function as we did before. Then we send our threads to our node with the same stuff as we did. This will just be a single message. In this case, we don't have any value, so we don't need a signature. Actually, the signature is being used for our message. And after it's successful, it will print our bundle. Let's see. There we go. It's really fast. So our message actually is this now. It's not readable, but luckily we have this excellent Tango Explorer right here. I don't have any stock in it, but it's excellent. It's still pending, that's okay. We can watch it. And there is our transaction. Still in threads, but there's a toggle here. And there we go. Our message has been converted into ASCII again using the probably one of these functions, the ASCII, the threads to ASCII. Threads to ASCII function to convert it back, and this is a way to send messages over the Tango. Now this is just a standard text message, not very useful. If you send something using Trinity, it does the same. But we can use this for some other cool stuff as well. So, say we have a sensor, and we don't care that it's public data. We don't want to use mem or anything. We can just send a JSON string in here. We can actually do that right away. So, say we have data. This is our raw sensor data. Temperature 20 degrees. My indenting is a bit messed. So this is basically something we fetch from a sensor in this case, and we want to send this as a JSON object. Now I don't know this out of the top of my head. I believe it was capitals JSON. JSON dot what do we have? Stringify? Yeah, stringify. So the JSON dot stringify converts our object to a JSON string. There we go. Works like that. JSON should be part of the standard library, and we're using JavaScript here, so we don't need these quotes, and this is just a number, so we don't need the quotes there either. It shouldn't be a string. In this case, let's make it 20.5. It will use a float in that case. So this is our data object, and this should work similar as before. So let's see what it does. There we go. If we go back to our address, we now see that our first has been confirmed and our second is already in there. Yeah, it's a number now. Triggered your OCD or what? And as you can actually see, this very smart Tango Explorer now notice that it actually contains JSON, and it shows it in a little more, in a little bit nicer way to display it. Confirmed just now. And this could be a very good way to send sensor data over the Tango. If you don't care if it's public or anything, you don't care about address reuse for messages, you can do it like this. If there are no questions, we'll check the fetch data function. No. let's change our yeah, it's so basically it doesn't look very useful right now, the JSON function, but if you have some more complex object, you can actually see the indenting and oh, what the hell, let's just try it right away to show you what's going on. Oh. We have plenty of time. So say temperature is this, and we have some history as well of our last temperature readings, which we want to send, because we might not want to send to the Tango every minute. We might want to send every 10 minutes or so, due to maybe bandwidth restrictions. If you're using, for example, LoRaWAN, you might want to bundle this data, something like that. So let's nest a history object in here, and we'll give it some random temperature values. 20.1, 19.2, and 21.3. Something like this. We'll send it again. Location long let, that's a good one as well. Yeah, nice. Let's check. There we have it. I actually sent this a couple of times. So here we have our JSON object. It's a little bit more complex now. But if we look at this, we can actually see, oh, we have a history now. We can even collapse it here. It's a nicer way to display if you're sending JSON data. Hey, junkies. 5.2 fetch data. So instead of the Tango Explorer, we can also use the library, of course, to fetch our transactions for our address. Let's get our address again. I believe it's this. Long and let domains. Yeah, I didn't even know these existed. Probably don't, but okay. So we have our address here. We find the transactions object, and since we are getting tries in a signature message fragment, we want to convert them back into ASCII. Slice 0, 1, response signature message fragment, slice 0, -1. Okay, it's doing some slicing here, not exactly know what it is about, but we'll have a look at it in a bit. So here it converts our tries back to ASCII, and we get our decoded messages. So let's just see if it gives us anything, if I did the address correctly. So here you can see this is our signature message fragment, and this is our decoded message. As you can see, it only got our first response. So we can change this to a 1 or a 2 or a 3. We can loop over it as well. Let's see if our tree has something in it. There we go. Here we have our temperature example with the history inside. And since this is actual, this is a string right now, so we can get it back into something more useful inside JavaScript, json.parse in this case. And this will take our ASCII string with our JSON, and it will convert it into a JSON object. And I need to mute my phone a bit, because it's buzzing all the time. And something went wrong. That's great. Data converter tries. What did I do wrong? Token 52, unknown token. So tell me, what did I do wrong? This is valid JSON, right? paste this. Why not? Paste. Well, I'm not sure what's the deal with this, but it's probably something very simple. In any case, that's a way to fetch your sensor data again from the Tango using the JavaScript library. Not feeling like debugging this right now. Not quite sure what's going on. Should be quite simple. Does anyone have any questions so far? We've covered quite a lot already in terms of sending transactions, receiving transactions, values, transactions, messages in transactions. We will be looking at something else right now. It's called ZeroMQ Listen. So basically, using the examples we did before, you can get transactions from addresses, read them, but you will always have to run a script to poll them. So you have to say, for example, run the script every 1 minute to check if there's a new transaction. That's not very that's not a very fast and efficient way to do it. If you actually have a service where you need something to happen live, so at the very moment when a transaction arrives, you can actually use ZeroMQ. And what this is some sort of a radio station built into the IRI nodes. On most public nodes they are disabled, but on the DevNet they are enabled. If you want to use them yourself on your public instance, you might have to enable it for yourself in your node settings. We will be using the DevNet node which has it enabled, so we can just have a look at it. What is the max size of a message before the POW increases? Let's have a look at the autonomy of a transaction. We have a signature message fragment. This is 2187 in length. So as soon as your signature message fragment, which is your message, exceeds this length in tries, you need another transaction in order to split the message over multiple transactions. So you can send longer messages as this, but you will have to split it over multiple messages. And yeah, so basically you will have to send another transaction. But like Mathieu says, it's not really related to the transaction itself. Every transaction you want to validate uses a minimum weight magnitude, and this doesn't differ based on the length of your message. There's no real limit, but there's a limit per transaction, but you can always split your message over multiple transactions. So if you really need and want to, you can send a very big transaction. You can even send files over the Tango. I wouldn't recommend it because it will be a lot of proof of work you will have to do in order to send all these messages across the Tango. Plus, it's not really... it could be quite slow. But yeah, as long as you split them over multiple messages, you can send as long as you want, I guess. It is recommended to not create a too big bundle, but it is possible. Yeah, it's a length in tries, indeed. So our address here is 81 tries. Our complete transaction always is 2,673 tries long. There's no difference in that. So if you have a shorter message, it will just pad it with 9s. No worries. Happy to answer the question. So to return to our ZeroMQ listener, ZeroMQ within our node actually it's like a radio transmitter. People can listen into it on a certain frequency or channel, and as soon as our radio station broadcasts that it has received a new message or it has confirmed a new message, it will send something over that channel, and the people listening will instantly hear it. So this is very useful to monitor our transactions in a real-time way. Sites like tanglemonitor.com, for for example, sites that visualize what's happening on the Tangle at the very moment. Here we have what's going on in the main Tangle right now. A pretty big amount of black spots. Someone might be spamming there. But yeah, as you can see, all these are live transactions. This script is definitely not asking the API every 0.1 second if the what the new transactions are, but this is actually using 0MQ to receive all these messages. So if you want to build something like this, or you need to intercept a transaction as soon as possible, this would be a very good way to do this. We can actually look at the transactions on the DevNet here. Pretty cool. But let's close it down for a little bit because we're going to look at our example. For this, we are going to use our 0MQ library, which we already installed. This was part of our npm install in our packages.json or package.json. So we installed this version 5.1 of 0MQ, and this is basically a client library for 0MQ. Yeah, it would be pretty inefficient to send long messages over the Tangle. If you want to send, for example, a file over the Tangle, a big file, it might be better to just use a separate channel to send your file. So, for example, you send it over some peer-to-peer connection or whatever, and you use the Tangle to do the encoding part or make sure that the pairs connect to each other. We have ion.oo, I believe. This is created by, I believe, one of the guys who worked on the ledger. He demonstrated this a while ago. And this actually uses the IOTA Tangle to video connect or connect two people to each other over the Tangle using WebRTC. And this allows you to peer-to-peer connect to someone, do a video call with someone without having to need a centralized service to do so. Usually when you do this, you need a centralized service which runs, which makes sure both parties exchange IP addresses and open ports, etc. But yeah, this is always a centralized service. They can lock your IP address, or they have access to your port info. You might not want to do that. You might not want to be dependent on that service, and this is a very cool way to use the Tangle for that. So have a look at that if you want to give it a go. It works pretty decent for peer-to-peer video connections. Hey, Marius. Thank you for watching. Hi from the Netherlands. So yeah, back to our 0MQ connection. It's basically some sort of socket connection, which we're going to subscribe to. First, we connect to our 0MQ port. 0MQ runs on a different port on our nodes. You actually have to enable it in your IRI if you want to use it. It's a setting. So we can have a look if you want to enable it at the documentation. It's probably right here. Or maybe not. It's a pretty hidden feature. Reference. Maybe not. It's in your setting for your IRI. It should be there and it should be toggleable. Let me see what it is. Let's see what Nurio has to say about this. So yeah, if you have a setting called ZMQ enabled in your IRI.ini and you put it on a true value, and you restart your node, you will have it available. That's a bit too much information, thank you. So yeah, make sure you have that enabled on your node. The default port is 5556. If you don't change anything in that setting, it should be the same. And it's always on TCP, I believe. We will be using the DevNet right here, so we won't have to deal with any node configurations for now. The DevNet nodes actually have the 0MQ enabled. Be careful. I'm not sure. We ran into some issue, but I think it was unrelated with the tangle.org, so it uses IOTA.org here as well. The issue was with, I believe, the depth, which wasn't accepted. But I believe no, I'm not sure. But Joe, does it have 0MQ enabled on the tangle.org nodes? We will be using this one because I know this should work. So what it says here, it will be watching, if we don't have any argument for this function, or second argument, it will be watching all transactions on this node. If you want to watch an address, you use your address. So we can listen to all transactions, or we can listen to a certain address. And here we are subscribing to our 0MQ socket. And what we're saying is we want to listen in to the transaction TX channel. So basically, if you compare it to a radio station, you want to be listening to this frequency or this channel. And this channel sends us newly seen transactions. So if a node receives a newly seen transaction, it will send a TX message, which will tell us there is a new transaction. We have things like TX strides as well, which will send us complete strides for the transaction. And we have other stuff as well. There is one for confirmed transactions as well, SN. So if we actually want to get a notification once a transaction has been confirmed, instead of a new transaction, we want to use SN. We can subscribe to multiple sockets as well if we want to listen to multiple messages. So yeah, and we can subscribe to a certain address as well, and this will only return things for a certain address, which is cool. Okay, so the Tango doesn't have the ZMQ right now. Yeah, it's a lot of bandwidth indeed. So if you have a public node and you enable 0MQ, please bear in mind that you will be sending out every transaction that's incoming to your node through 0MQ to everyone subscribe to you as well. So this can be a lot of bandwidth. If your node is very popular, like the tangle.org nodes, you might not want to have this enabled unless you have a lot of funds to afford this, or a lot of bandwidth for free. Yeah, you might want to be wary if you use your home connection for that and have a public node. Some ISPs might not like your bandwidth amount and might give you a notice about this. So our socket library or a socket object actually receives messages, and this listener actually calls this function once it receives a message. Since we subscribed to transactions, it will be called every time a new transaction arrives. It will split it into the topic and the data. The topic is transaction or SN. And if it's a transaction, it will tell us what the transaction is. My syntax highlighter is going a bit crazy on this. I'm not sure. Maybe these quotes are a bit weird. We'll see what it does. Node 6. Let's run it right now without any arguments. Is this a problem the marketplace has? SensorStream has a huge amount of listeners. The marketplace, I'm not sure if it's something the marketplace has, because you're listening to a node, not to the marketplace. I think I'm not really sure if that's true. Let's run this example first, and we can get a little bit into detail first. So Okay, we actually received a transaction here. What it's doing now, it's actually printing out all transactions we have on the DevNet right here. So if I actually reopen, no, not that one, the tanglemonitor.com, we should be seeing the same for the DevNet. Well, not exactly the same, because it depends on your node as well. Different nodes receive different transactions at different times, so it might be exactly the same or exactly the same order. Why use a switch with only 2 options? Well, because we might want to do some more later on. For example, we might want to listen to confirmed transactions as well. I will actually add it in a little bit. So we don't see anything new coming in right now. Oh, there we have a new transaction. We don't see it here because this is probably using a different node. Oh, here we have a whole block of new stuff. Well, this is a great way to listen to new transactions. This might go by really fast if you're using a production node. But say we want to listen to our own address only. So we have our address right here. We'll copy it right without the checksum part. Let's listen to our own address right here. And let's send it a new transaction. So I need a new tab. I will log into my virtual machine and type my password incorrectly a couple of times. IOTA workshop, code. Let's send data. Because I already have my address in there from our previous example, I will just run this one time. Is this the right address? I think so. Hello world, hello world, hello world, hello world, hello world, hello Twitch. Hello world, yeah. Oh, I need to be patient. I'm not really patient. But in any case, once the node in our definite node cluster receives this transaction, it should pop in here without us having to poll for it the whole time. There we have it. This is our transaction which we just sent. What do you mean, cone? Sorry, I don't get what you're saying. TX shows timestamp. If you want attachment timestamp, you need to listen to TX trites and convert to trites. Yeah, exactly. You might want to listen to TX trites for some more info. We just have some really basic stuff right here. But let's edit a little bit to make it a little bit more interesting. I think I can just say I want to listen to confirms as well. And let's change this to TX trites. Let's see what that gives us. Now, I don't know for sure, since we are subscribing to this address right here. All topics must be lowercase, do not clash with address, continue the topic. Okay. Okay, so we're basically listening to our address here. I'm not sure if you can combine this with the TX. We definitely need a good tutorial for the zero and pure interaction because it's really useful. But let's just see without us having to send a new transaction what this gives us. So it should give us both confirms, so confirmed transactions and the transaction trites for our transactions. Yeah, so say I'm the radio broadcaster. I have a 0MQ stream and everyone is connected to me. I will need to send out all transactions sent over the Tango to all these people who are listening to that. So if I have 100 people connected to that and a transaction is, say, 2,600 tries, so a whole bunch of bytes, and I have 20 transactions per second, it will be a lot of bandwidth in the end if you send it to all 100 people. So you will have need to have a high bandwidth connection, and it will use a lot of bandwidth in the process, a lot of gigabytes. And indeed, a lot of ISPs have fair use policies. So if you have a couple of 100 gigabytes, they might not have a problem with it. But if you are doing terabytes, they might complain and might even say, if you do it again, we'll shut you down. Not the first time it has happened. No, because a sensor is sending data to the Tango. A sensor is basically not using 0MQ. 0MQ is purely for listening. What a sensor does, it connects to a node and it sends a transaction. This is only a very little amount of bandwidth. Then the whole, the sensor itself won't have any listeners because the sensor is pushing data to a node. The node sends these transactions to its neighbors. Neighbors confirm it. Neighbors send it to other neighbors, and this way it propagates over the whole network. And if someone wants to listen in to the sensor, it actually connects to a node and listens on 0MQ to that node. So it's not listening to the sensor directly, but it's listening to the sensor through the node. This means that the sensor will only use the 2,000 tries for sending the transaction, or 4 times 2,000 tries for sending the transaction. And the node will be responsible for propagating it over the whole network and having people connected to it over 0MQ. So yeah, I hope that answers your question. Not quite sure why it's not working now. Maybe it doesn't like this. Or maybe it doesn't have any transactions at this moment. Oh, no worries. I hope it was it was useful. But yeah, that's basically how it works. Sending a transaction is sometimes people think it's magic, but it's not. It's pretty simple. You always connect to a node. A node is your entry point into the Tango, and this node has a certain amount of neighbors, and these neighbors connect to other neighbors, and they all send their messages to other neighbors and neighbors and neighbors and neighbors. And in the end, everyone connected to the main network that is in sync will have those messages available. Yeah, this could lead into a lot of data stored. This is why we'll have local snapshots later on. I'm not quite sure why we're not receiving any more transactions right now. Maybe nobody is using the testnet at the moment. Could be it. Maybe something is broken. Oh, there we have another transaction. Maybe I need to listen to both TX and TX strides. I will do a bit of work on this later to make sure that this is well tested and well documented as to what you have to do in order to receive this additional data as well for the transaction using 0MQ. But yeah, this is already a useful way to look at if a transaction is either confirmed or received. If you want to do something in real time, that is what you use the 0MQ for. There is some documentation about this inside the error repository right here. It's linked on the IRE docs at 0MQ. And yeah, there will be more tutorials and documentation about this soon, so it will be easier to interact with it and without a lot more experimentation. Does anyone have any further questions regarding 0MQ? If not, I will continue to to continue with MEM, Master Authenticated Messaging, which is quite cool, exciting. Like I mentioned before, the current version of MEM is sort of a prototype version, like a proof of concept version. There will be a new version available soon, which will be better tested. It will be available in C, actually. It will be built in C, and it will be ported to client libraries as well. So there will be a JavaScript library for it as well, probably other libraries as well. And it should be a really easy way to send messages over the Tango, either public, private, or restricted. There are 3 modes at this moment. And they all have a different purpose. So let's have a look at our first MEM example, a public send. So what we're going to do is we're going to use Master Authenticated Messaging to send a stream of messages to the Tango using the MEM library, which we included right here. The Tango monitor is slowing stuff down, so let's close it. We include our MEM library. We include our ASCII to trites function, since we want to be sending trites through our MEM message. We connect to a public node again, and we change our mode of MEM. So we initialize MEM. We have a MEM state here, which comes from that. We will have to pass it if we want to do something with it. And we set the mode to public. Public means that everyone with access to the address which you're publishing to will be able to read your message. Minimize it looks like ham, yeah, maybe. But that's the way it's called in this example right now. So we're sending a public message now. We don't care about privacy in this case. We just want to send the message, and we don't want to encrypt it or prevent anyone from accessing it. This is a great way if you want, for example, to send your temperature sensor data to the Tango, and you don't care about monetizing it or anything. You just want to give it to someone. Use the public function, and everyone with your root can access the stream of data. So how does this differ from just sending a message in your regular transaction? With MEM you use a Merkle tree. So basically what you do is you publish your messages to several addresses, but your address differs from time to time. But MEM will know what the next address is. This is based on a Merkle tree, so it can calculate based on the address you're listening to what the next address that will be published to will be, and it can listen to that. You don't have to think about this in detail, because the MEM library will do all this for you based on your modes. But yeah, it comes down to that, I guess. So we create a new MEM message with our data. This is a asynchronous function as well, so we call it 2 times here. We actually publish two strings. How does it know what the next address will be without knowing the seed? That's a good question. The seed, with a public message, I believe the seed is known because it's a public message, where so it can use the seed, the publicly known seed, as a way to calculate the next address. If you use restricted mode with side keys, you can actually, we'll go into that in detail a little bit later, but you can actually say, okay, we change the side key, and from this moment on, people won't be able to receive any new messages, because the new addresses generated won't be the same as what the people are expecting. But yeah, it basically knows. Never use a public mem message for something you want to keep private, of course. With private, it's a little bit different, but yeah. So we create our message. We include our trites here. So we converted our data into trites again. Again, really straightforward process. We just encode them into trites. We create a new message. Update the mem state to the state of this latest message. We need to, this to set. So the next publish action knows its state. Okay. Mem state. Do we actually use this here? Oh yeah, it updates the state of our. So this calculates a new address and it updates our state. So we need to set it in our state object because we want to use our publish function 2 times. So we need to make sure we don't publish to the same address. Then we attach it using the mem library. Our message.payload is the payload. We send it to our address, which is also generated inside our message based on the mode we are in. And we attach it with 3 and 9, a depth of 3 and a POW, a minimum weight magnitude of 9. This is for the testnet again. For mainnet, use 14. And once it's done, it will publish our message.root. And we will have a look at that in a little bit to see the difference between public, private, and restricted. So let's try this out. Let's change these to messages just for fun. Hello Twitch. This is our first mem public message. Okay. Let's see if it works. Okay, so it did send 2 messages to the Tango. The first address is this one. Ooh. A couple of transactions in there, signature. Okay, they already confirmed. Yeah, address. Okay, so that actually worked. And the second one was sent as well. As you can see, it sent it to a different address. This isn't very useful in the Tango monitor at this moment. But there are other ways, and we're going to look at that right now. So this is the root. As you can see, this differs. But this one, this is the first message I sent. This knows what the next address will be because it's public. Thank you, Mathieu. That's a lot more useful, I guess. Awesome. So it asks us for our channel ID here. This is basically just your address or your root. We will enter the first address. This is the root of our first address, and this will know the second address as well. Let's see. Load more. No more messages to decode. Text. This is our first mem root message. It should know our second as well. Not quite sure if that works in here. Hello Twitch. It's the other way around. So it knows our previous what? This hello Twitch. This it was the other way around. So I looked at the looked at it in the wrong order. It actually finished since it runs asynchronously. It finished our second message first. So it switched over. That's a bit confusing, but basically this is our first message. And as you can see, both messages show up here. This is the root of our second message. And this only shows our second message. What this means that with a public memstream, you can actually decide where you want to have the person listening to start from. So, for example, you have a temperature sensor that's been running for 6 months, and you want to give someone access to it, but you don't want to give access to the historical data. You just send them the root of the last published sensor data, and it will only show the messages from that point on. Children spawn parents for mem. Not sure if that's the right right thing to say. Let me get a Merkle tree image right here so I can explain that. So let's say we have this thing right here. This is our root address for our first message. This is like this address. Say it creates a message. This is my first message. This is my second message. If I know my first message, it can. Not sure if this is the best image for it, but or am I reading it the wrong way around? Yeah, I'm probably reading it the wrong way around. But the thing you have to remember is that if you have a root, you can see everything that's published after that, but you can't see in the past. So it's like a stream forward. You can see of it as recording a radio station again. So you can record anything from the point you start listening, but you can't listen to anything from the past. I hope that makes a little bit of sense. So we did this. Public mem create writes. So let's do another one. And this time we will add some extra so I can show you how this works. And now I'm going to include my message here as well in the log so I can see what the order is in which they are received or sent. Because that wasn't really clear. Data. Let's do it again with 4 messages this time. This is you see the third, second, hello Twitch, and a first. So the order is totally different. Hello Twitch is our first one. So this should show all our messages. Hello Twitch, this is our first public message, this is our second, this is our third. So that's all right, exactly what we needed. Now let's look at our first message, this one. This should have everything from this point onwards. This is our first public message, second and third. And yeah, exactly. So my code doesn't guarantee the order of the published. Your code doesn't guarantee the order of the published messages. That's true. Something to keep in mind. But yeah, you can just distribute the first root if you want to give complete history. But you can also say, I just want to give you history from this point onwards, and they won't be able to look in the past. So that's the public message sending function. Let's have a look at something with a little bit more private data. This is not private, this is restricted. And this example is, this is restricted mode. Okay. So you have 3 modes. You have public, private, and restricted. We currently show you the public one, which is available for everyone with your address. And they will be able to see everything in the future as well. And then there's private and there's restricted. There's no demonstration for private at this point. but there is one for restricted, and the difference from private as compared to restricted is that it has a side key, a secret. The other party needs to know both the address and the secret in order to know what the next message will be or what the next address will be. So even if I know which address this is published on, I won't be able to have a look at it. And yeah, private is with encoding as well, so I shouldn't be able to publicly read it, I believe. Let's just try that out with our previous example. Let's just change it to private and see what happens. Hello Twitch, this is our address. Let's see what this Explorer will tell us. Does not exist or has no messages yet. That's interesting. This is probably because we send it as a private function. Let me see what the message at address. So we have a message at root, but we also have a message at address. Takes a little bit longer now. I think Mathieu is rate limiting me. First, root address, address. As you can see, both differ. Or do I need to use this side key? Let me check. So I think the public mem decoder just looks at publicly encoded. I think the Explorer only looks at public streams. I actually can't enter a secret here as well for the private function. Let's have a look at the receiver function, see if we can get it to work. The root address. This is our first. Yeah, it says public. Well, it's great for public data, but keep in mind that you won't be able to look at the private or protected messages in this case, which is fine. I think this is a great way to debug to see if your mem stream is working in public mode. Okay, so we actually fetch it in private mode now. This is our side key. We don't have a side key in private mode. Let's see if this works. There we go. So we know our address now. We know the forward way. But we can just access the private data from here. But theoretically, library would get you the encoded decoded message if you provide the address. Yeah. So if you have the address, you will still be able to see it. I'm not quite sure what a good use case for that would be in terms of public versus private. Someone might explain. Yeah, true. But one thing I think that is very interesting is the restricted mode. Like I said, it has a secret with the address as well. In this case, our secret is int don't share this. And what the secret does is it makes sure that you won't be able to see the next address for a message stream if you don't have the right secret. And the cool thing about this is you can continue a stream as you want. And if you want to say, okay, I don't want the people to have access to new data in my stream anymore. You can just change your side key and distribute the new side key to people that you do want to have continue to give access to it, and they will still be able to listen to it, but the people that don't have the updated side key, they won't receive any updates anymore on your stream. So this is a good way to actually revoke access for data on the Tangle through mem. I think this is a very useful mode for sending data if you want to keep things a bit more protected. So here we go again, exactly the same as the last example, but with a side key here called mem secret. It's called side key in mem. We change the mode to restricted. We give the secret. We convert our data into tries again. We preserve our state. We attach it to the Tangle. We show our root address here. And here I will log as well what our message is, so we know which one is first. Super secret message 1, super secret message 2. Node 7.3. There we go. We won't be able to look it up here, but let me see. No, I don't want it. Okay. This is our root. This is a root I copy pasted from our first message. It has a restricted mode and it has our secret here. So we connect to our node again. We have a function to log the output of our mem stream, and we fetch all messages based on the root, the mem type, and the secret. So it should give me my 2 messages now, hopefully. Takes a little bit. Not sure why. Yeah, member restricted does have a lot of use cases, and it's really cool to have a way to revoke access on the Tangle, because it's just a publicly available data stream. It does make sense to use this mode. Yeah, it would be a nice way of really data streams. I think data marketplace kind of data, where you maybe want to work with subscriptions, where your side key is revoked after each month of data and you have to resubscribe. That kind of stuff could be pretty useful for these kinds of subscription-based things. I'm not sure what it's hanging on. That's I'm very impatient. Let's check the code again, see if there's something weird here. Nodes.dev.iota.org, is that different from 7.2? It's just the let mom state is just my JS server being fast and the IOTA.org server being slow. I guess. What went wrong? Is this the stuff with the... No, we're not doing any proof of work. Did I make a mistake with my address? Super secret message. Maybe I just got the wrong address here. Is this different? st. Yeah, it's different. I got the wrong copy paste. So it didn't have any messages there. And there we have it. So these are the two messages it fetched. If I want to fetch this data without my secret key, for example, if I add Dave here, I don't know the secret key. I just won't be able to access it. It gives a bit of a weird Rust error because mem was actually created in Rust. But it comes down to you won't be able to fetch your data without the side key, without the active side key at that moment. So yeah, a really useful way of utilizing mem for more private data, a more controlled stream of data where you want to have some kind of access management. And then we have our last example, and I guess we'll call it night after that. This is a public, let's see what it is. Enter the root, listening to the mem stream, check the mem stream every 5 seconds. Alright, so this is like a function where we listen to the mem stream every 5 seconds and do something if something happens. So this is really good for if you want to monitor a mem stream, want to see if, for example, a sensor has published something and do some extra action based on that. So maybe you want to call an API endpoint or something. This will make you do this. So let's make sure we have a stream first. Public send. We'll do this in another console. Let's combine these two maybe. Let's do a little bit of coding because we have only looked at code so far. Okay, I'll just quickly copy paste this. Not sure if this is going to work. Okay. Publish. Let's return our message.root here. And we do our init function here. So I'm changing my code around right now. I just copy pasted this part right here for sending public data to the Tango on a new endpoint. Let's change this to public because we want to listen to a public address. First we publish our hello Twitch, and this will return our root. So const first root is this one. Then we're going to initialize our mem thing again. I don't think we even need this because we already did this. So we can get rid of that. We have our root already. So we do check mem, root is next root, check mem root. Root is next root, or we have const root here. First root. We'll just call it root here because we're going to update it. Root is next root, root is root. Okay. We will fetch from our root and show data. Where is our show data? Doesn't even have the show data function. I think this is a I'm not in the right example. Show data. Right, we don't even have to. This example isn't even complete, so this needs to be changed a little bit. After this example, I will be wrapping up the stream because we covered all topics and it's a little bit to digest, I guess. If you can think of any questions, this would be the right moment to think of them and put them in the chat. So let's put our show data function in here as well. It's a little bit of a mess. Not sure if this is going to work. And this logs here. So this will both send and receive at the same time. And it will keep checking if there are new messages with the receive function every 5 seconds. So let's see if this works. I probably made some mistake because I did it really quickly. Yeah, I made some mistake. Unfortunately, this is not very verbose. I heard that you can connect only 2 devices with IOTA. Is it true? I'm not sure what you mean with 2 devices, but I don't think it's true. If you have a device, it has internet access, it can do the required math to access the Tango. You can connect any kind of device. You currently have people pushing data to the Tango through Raspberry Pis, to Bosch XDK devices, RubyTags. Bosch XDK and RubyTag both have libraries available for the platform that interact with the Tango, but you're not limited to that hardware for interacting with the Tango. Basically, anything that runs arbitrary code, has access to the internet and enough power to create these low-power transactions should be able to interact with the Tango. Plus, you can also have like sensors that work on a different protocol, maybe LoRaWAN or example. Stop trolling me, Mathieu. So you can have sensors connected to a LoRaWAN network, and those sensors are not powerful enough and don't have enough bandwidth to interact with the Tango directly, but they can connect to a gateway, and that gateway can be connected to the Tango. So indirectly, they will be available on the Tango as well. So no, I don't think there are only 2 devices. Let's see if I did anything stupid in here. Could well be. Return message root, publish. Check, man. Yeah, this is one of the things. Thanks, Hunter. It's nice that we have people here that are just watching for me. It's kind of weird as well, but I guess that's fine. Yeah, this is one of the things I really don't like about Node.js. If you have things like error messages within your async functions, those won't log by default. It will just return empty messages and you don't know what's up. There are some ways around this, but I think this is a bit outside of the scope of this example. What I'll do is I'll have a look at this last 7.5 example, maybe issue a pull request to get it to work in a way that you can actually monitor it. But right now it's not working and the error message is unknown. So let's skip this one for now. It's not a lot different as just fetching the public addresses. It's just fetching the public addresses with a 5-second interval. So yeah, I think we'll leave it at that for tonight. And we don't have a tipbot in the Twitch yet. I believe tipbot creators of the Discord are working on it, but that might actually cost you 5 IOTA in the future. Yeah, no tipbot yet. Thanks. Ooh, that's a nice suggestion. Very, very smart of you to notice that. So constant is basically a variable that's not changing, but we are actually changing it. So that might actually be it. We'll change it to let in this case, which is a mutable variable. Someone is actually paying attention. Fortunately, that wasn't the problem, but it was a good catch, and it was something I did wrong. So good one. Are there any further questions? Do you have any suggestions as to what you would like to see in any further stream? Because any topics as well to cover, otherwise there won't be a lot to talk about. Things that I still have in mind to stream about. I want to create a Raspberry Pi sensor that I connect through a mem stream to the Tango. But I will receive some hardware for that. But this might take a bit, so maybe in a couple of weeks. Another thing I want to do is set up a private Tango using Compass, so a coordinator, so I can explain how this process works, but also how the Tango, how a little Tango works, and where the ledger states are stored, how the coordinator works, what it actually does. Maybe I can do something with Hub as well. I really wish to see the public watch in action. Okay, well, let's do it like this. Then I will remove my. Shut up, Alexa.
I don't have an opinion on
Shut up. No. Unplug. We don't want it. Listening to my conversations. So yeah, I'll just revert it to what it was, and we'll do it a little bit differently so I can demonstrate it. I think the problem is with my combined sending and receiving function, so I will just do it separately. So what I'll do is I'll create two functions, or I change my 7.1 function. This will publish these messages. Let's see, we'll create a function. Send message. And this function will send this. And we'll create a counter. And we'll increase this counter every time. This is message. Let's start at 1. Yeah, exactly. It comes down to that. It's really simple, but let's just demonstrate it for this purpose. This is message plus counter. Nice and nasty JavaScript. Set timeout, or set interval in this case. We want to keep it running. Send message 5000. So we're going to send this message every 5 seconds. Let's see if this actually does something. There we have it. This is our first message 1. Now we're going to watch our 7.5, and I have it open already somewhere, but and we'll paste our root here, and the show data function wasn't in here, so I'll get it from 7.2, so it won't break on that. And what did I do it right? Yeah. Node 7.5. Is it this thing again? Definite.iota.org. It's actually breaking on something. Oh, oh, no. Abort. I still have private in here, so that doesn't work. Needs to be a public message for this example. We'll get a different route this time. Public watch. Yeah, we have to be really careful with these examples if we change anything, because as you can see, it's really easy to break stuff. And the errors are not very verbose. Hopefully the new mem library will have a little bit more verbose errors. I will really try to get that done. Still nothing. Maybe something with the node, no. Fetch root. Did I copy the right address? Let's check it in the public mem decoder. As you can see, the root address and the address are the same here. This is different for private. Twitch message 2, 3, that's okay. So did I copy the right one? Yeah. That's okay. So what am I missing? Threads to ASCII. I have that available. Is it the way the function is created? Let's just do this function show data. I don't like all these different types of declarations. I'm not sure what the difference is. No. Okay. I am going to do something real quick to debug it. High mobility blueprints. Did I? Oh. Did I really? Where is it? Public watch. Damn it. Who put this in there? No, it's not a problem. But it is a problem. Let's see the high mobility blueprints. And I have a neat little package in here, which I'm going to use. It's called unhandled rejection. And no, not pip, we're not in Python. npm install unhandled rejection. And then I have some boilerplate for that right here. Calling an async function from the global scope. Init mem check mem. Do I have those available? Init mem check mem. That's okay. We can do that. No? We don't have any awaits in here. It should be fine. How is this called? Error handling.js. So this will basically hack us something in here where we can debug what's going wrong inside our async functions. Require, I'm a little rusty on the syntax, error handling.js. But this isn't the problem, I guess, because we do this in 7.1 as well. Send message interval. Oh, this is no, this is for sending the message. Publish. Yeah, we call this publish here. This is global scope as well, and this is an async function, so that's not a problem. Why is this not verbose? It's stupid. Let's. Ooh. What? Set interval, send message. Oh, I did cancel it there. Okay. And now this is broken as well. Great. Let me check the base bin. I need to await the init mem, you think, yeah? So this is what you shared. Let me get in here. I'm lazy. No. No. I didn't have any problem with that before, but yeah, just in case, could be a race condition indeed. It's a good suggestion, but this is probably something really stupid again. Maybe. Let me check. Await mem.init. Maybe the state needs to be set here already, or no, we don't use state. Let's see, it's just a node acting up. Unfortunate. I will have a look at it, and I think this example needs update as well because it's not complete. You're not passing anything in show data. Let's check. Show data. No, this is the callback. The first argument for the callback will be the message. So yeah, the callback will always receive a message in here. We're doing the same in 7.2, and that worked in there. So that's not the problem. But yeah, I'm not quite sure what the deal is with this one, and my error message is not existing at all, which I don't like, because it won't give me any clue as to what actually is going on. I could always say try some console logs, see what's going on. Mem initialized, check mem root for fetch. It's a nasty way of debugging, but it works. Maybe we can get some clues as to where our error is at this point. Mem initialized, it isn't even going. So this worked, and the check mem function, async function check mem, it's already, oh, next route isn't available. Ah, there we go. That next route. There we go. Before fetch. Okay, we're getting somewhere. Yeah, classic. But now it breaks on this as well. Not quite sure what the problem is with this. Await mem.init, mem.fetch public root. We have our root. If root is different from next root, then the root is the next root. So it sets the next root to this one. I'm going to be lazy for this. There are better ways to do this. I'll just copy paste it. Our next root is root. This. Now it should work. There we go. Nice. Now we have our listener. It's up and running. We can remove our debug data and we'll try again. Who needs error messages, right? So let's leave this open because we need our address first. And we'll run our sender again. This will send this message every 5 seconds. There we go. Here's our root address. Since it's public, it's the same as our address. We'll paste it right here. There we go. And as you can see, it has 4 messages now. It's publishing a new message every 5 seconds. So it keeps running through these new messages in our mem stream. And this would be a perfect way to, for example, monitor a sensor and do something with that data based on a tangle without being directly connected to the sensor. So this is completely independent. I can connect to another node if I want here, and it will get the same messages. As long as I have the root, I can have this message. And for example, I want to give someone else access, but only from this 9th message onwards. Okay. Then I'll just remove this root, enter this one, and it will only show me the 9 and the 10 message and every message coming after that. So we actually got it to work this time. Yeah, this last example needs a bit of work, but it's not that complex, I guess. We should get that fixed. I personally think this is a very useful way of getting to know IOTA and the basic functions by having such a repository. If you want to have it as some sort of reference or try it out yourself, you're very free to do so. I'll link it again in the chat for anyone interested in trying it out yourself. And with that, I think I'm going to call it, unless there is unless there are any more questions or suggestions or whatever. Everyone can send me suggestions of anyone can send me suggestions for new streams. I will all consider them. I will give priority to other things if they're more interested. But what I did is I installed the latest Ubuntu server LTS version. This is with a new Ubuntu installer. I can really recommend if you're using virtual machines like me to use that, because the new installer it uses is really quickly. You can set up a new virtual machine even if it has only a gigabyte of memory or something within minutes. And yeah, so it's basically a clean server. And the only thing I did was I added the multiverse repository. I installed Node.js. 18.04 comes with Node 8.10 by default, which is fine for our use case. So we didn't have to upgrade our Node. One nice thing with Node, you have a package called N, like N, this. We need to install it globally. And we need to do it with sudo because it is going to be installed globally. And what this allows us to do is to switch between Node versions instantly. So you can see say we want to go to the latest version of Node.js. I'll say sudo n latest. It automatically fetches Node 11.5 for me. And we might have to do a little thing or two to get this to work, but maybe. Yeah, so this doesn't work right away. This is because the links to the right binary aren't made. But this is something, let me see, which node? Maybe I can just remove node. See if that works. Maybe I messed it up now, but this allows you to easily switch between node versions. If you need a better version or another version for a certain project, you can use this. User local bin node. There we have it. So I can now say I'm now going to link this to user bin node. So it works in my path. This is just something because I messed up with the installation. And now I have node available, and as you can see, it's version 11.5 now. Say I want the latest stable version, I can just say sudo n stable, and it will install 11.4 for me. And if I check my version right now, we have 11.4. So this is a really quick way to switch between Node versions if you need to. I'm not a Node expert, but this is one of the things I know to use, and it can come in really handy because certain libraries don't work on certain versions of Node. Okay, I don't see any further questions at this point. If you have them, ask them. If you have suggestions for any next stream, you can find me on Discord. I'm usually there. Any idea to improve the Tangle.org? I think it's amazing, Michel. It's a really great way. One thing, but I know it's hard to do, and probably a big burden on server capacity is to access all the transactions as the latest 100. And I really like. I didn't actually see the mem explorer thingy you have, but it would be cool if you could enter a private address, a private route, or a restricted route with a side key as well, so you can explore those as well if you're trying to debug those. There aren't a lot of good working mem explorers at this point, so I think that's something that could be worked on. But let's discuss that further on the Discord if you like. Thank you all for watching, and yeah, great to have some people interested in this. If you want to watch it back for a certain example, there's a video on demand available. You can click on videos right after this stream, and you should be able to watch it back. Could I please post it on Reddit next time you stream? Yeah, for sure, I will do that. Thank you all for the thanks. It's a pleasure to do this, and I really hope that at least someone learned a little bit about it, and maybe it inspired you to do something with the IOTA technology yourself. Thank you all for watching, and I guess see you next week, maybe, maybe not. We have Christmas coming up. Not sure if I will be streaming this week. I do have some free time, but we'll see. I will let you guys know on Twitter, Reddit, and Discord. And I will make sure that the 7.5 example for MemPublic Watch is going to be fixed so that it's nice. Yeah, it's all Lewis's code. I have to give Lewis credit for creating this stuff because all I basically did was walk through his examples and demonstrate them. And luckily, most of them worked, apart from 7.5. So I was happy with it. I didn't have to write a lot of code myself. Okay, have a good night, and talk to you guys soon. Bye-bye.